Hello, welcome to the Snoretox presentation for Bio2020. I'm Dr. Tony Sasse, and on my left is my colleague, Dr. Tom McLean. So, what drugs do you know that will improve or treat diseased or weak muscles? The answer is none, until now. The story begins in India many years ago, where I was working as a junior doctor in a rural hospital. And I saw brought to our hospital many cases of tetanus, where patients would come in with their muscles having a high level of activity. They would be in spasms, they would be twitching, and they would be tetanic. And the question arose in my mind, how can we adapt that powerful molecule for safe and therapeutic indications in humans and animals? And that is what we have done. Tom.
So we have really great evidence that tetanus works in humans. We've got years, decades, centuries of people getting tetanus. So we know it works. So really we had two goals. One was to make sure that it was safe to use. The other was to make sure that it's effective to use as a therapeutic. So Snoretox started out by proving that they could use it as a therapeutic in a bulldog. And this bulldog, like many other bulldogs, had sleep apnea. And through treating it by injecting tetanus toxin into the right muscles, Snoretox was able to cure this dog's sleep apnea and really made its life much, much better. Now that was great. But when it comes to humans, and indeed a lot of animals as well, there's a major problem. And that is an immunity to tetanus toxin, caused in humans by vaccination, in animals either by vaccination or exposure. So our first challenge was, how do we make the toxin work when someone is vaccinated? And to do that, we modified the toxin in a way that it avoids the immune response. And we've patented this technology. So we took mice, we vaccinated them against tetanus, and in this way they modelled what a human would be like when they're injected. And we injected them in the hind limb with our toxin, our modified toxin, versus tetanus. Native tetanus. And you can see in the photos, on the left is a vaccinated mouse injected with native tetanus, and on the right is a vaccinated mouse injected with our molecules. And the difference is pretty plain. Then when you move over to the graphs, in red is vaccinated mice injected with our technology, and in blue is vaccinated mice injected with tetanus. And you can see our technology, our molecules work fantastically in vaccinated animals where at the same dose, the tetanus doesn't. And particularly, I want to draw your attention to the lower graph. What we've shown here is that our toxin works over a much, much wider range in vaccinated animals than the native tetanus does. And this is really important because it increases the safety of using it as a therapeutic. If you're injecting a patient with a toxin, you don't want to accidentally overdose and cause damage. This much, much wider range means that if you do overdose, the overdose is likely to be much milder or no effect at all. So really, in two ways, we've had massive success. And it's led us to the point where we have prototype therapeutic molecules ready to go. We want to take these into clinical trials to treat both veterinary conditions in brachycephalic dogs and possibly in laryngeal collapse in horses. We also want to take it into humans where we can treat a very wide range of diseases. Thank you.
So let's have a look at those potential markets. Firstly, let's think about snoring and sleep apnea. Over 1 billion patients globally and still no elegant solution. We hope to change that. Secondly, the veterinarian indications that Thomas just discussed. There's millions of dogs who will benefit from our discoveries. Thirdly, cosmetic indications such as chin lift, facelift, droopy eyelids, and particularly ectropion, an uncomfortable, unsightly drooping of the lower eyelid in elderly patients, and a simple therapeutic approach for that would be highly desirable, and we think we've done that. Finally, there's neurological indications such as MS, motor neuron disease, myopathies, anal incompetence, indeed even esophageal incompetence. These conditions basically have no therapeutic drugs available for them of any utility, and we indeed hope to change that. So the key features of our drugs are that, firstly, long-lasting, 4 to 6 months per microinjection, Very small doses required with we believe, a wide therapeutic margin, but if reversibility is required, then Botox would be the natural reversant. Investment highlights: it's a world first-in-class patented drug, and we've received favourable treatment from the Australian Government in terms of grants and research assistance, which will continue into the future for both us and our investors. We've put together a strong team, and finally we have institutional support from RMIT University and St Vincent's Hospital. So we're very confident looking forward to the future, and we're looking forward to collaborative arrangements with potential companies overseas. And if you have any questions whatsoever, please don't hesitate to contact us. Thank you for your attention.